let's continue on the tutorial. And in this next 30 minutes, I'm gonna touch on how we handle publisher mobility in supporting different NDN applications. And you heard from earlier this session, we work on the different kinds of applications, including the AR/VR applications, in which case a lot of times there are mobile nodes, they're generating data, and they are on the move. So the question is, how do we actually retrieve the data when the producer is on the move? Before getting into details of NDN, let's just reflect a little bit on the IP mobility. So when the host moves in the IP network, when the host moves from one network to another network, you have to get a new IP address, because that's how the IP works, how the routing works. So you need to have an IP address of your local network. And this usually breaks a couple of things and make all the applications' life suffer. One thing is all the ongoing TCP connection will break, because TCP connection is pinned down on the source destination addresses. If you change one end, the whole connection is going to break. And another thing is, of course, due to mobility, if you want to reach or initiate a connection to the mobile nodes, you cannot. You don't know what is the current location or current IP address. So you need to find a way to learn that. And then, of course, over the years, there are so many solutions have been proposed, and for example, mobile IP has been standardized. But if you look at all the IP solutions, they all share the same purpose, the same goal, is keep tracking down where the node is. So if the node moves, you have to keep changing your routing or your information in the system, trying to keep up where the node is. And if there are more node moves, then you have more work to do. So it's a tough, difficult problem of keep track of the moving target. With NDN, the problem becomes a little bit different, because even if a node moves, no matter consumer or producer, even the node moves, the content doesn't change, and the name of the content doesn't change. So now the problem has changed from tracing the moving node to retrieving the content, which may or may not move. And the request, so if imagine if you send a request, and no matter where you are sending, even you are moving around, you send a request, the request can keep going to the source or retrieve content from the cache or somebody around you. You don't need really, it's not required to have end-to-end connection from the requester to the producer. It's possible, it's a DTN situation. It's possible you never have a complete working end-to-end connectivity from the consumer to the producer, but somehow you can still get data, because nodes can retrieve data and move there like data link. If we look at more details in NDN, if the consumer moves, the producer don't move. If you just consider the consumer moves, we don't need anything actual. Everything just works out of the box. The consumer will keep sending interest, and if the interest doesn't get answered for whatever reason, the consumer can retransmit the interest. The interest may go all the way to the producer, get data back, or it may hit a cache in the middle, because the first interest retrieves data, but the consumer moves to a different location, then the second interest may hit the previous copies brought down by the first interest. So it's not like in the TCP/IP, if you move, your ongoing connection breaks, you have to do something. But here, there's no concept of end-to-end connection. There's no concept of TCP connection sessions. It just keeps sending the interest that the data for the data that you want, you haven't received. So consumer mobility is trivial here. The producer mobility is a little bit different. because when the producer moves and you send interest, suppose there's no cache, no data mill in the network doesn't know where to forward the interest to get the data, assuming only the producer at that moment has the data. Right? So we need a little bit of help here. But when I talk about in the later slides, I may say, oh, the interest go to the producer, this and that. But keep in your mind, this is NDN network. Even I say the interest go to the producer, it may hit a cache or data mill somewhere in the middle and come back. It never require a end-to-end connection. So, what are the possible solutions? What are the, on a very high level in this solution space, what can we do to support producer mobility? So if you, from the consumer point of view, I send interest and I don't know where the content might be. One way is you broadcast the interest to everywhere in the network. It's guaranteed to find the content because interest goes everywhere. Of course, it's too much overhead if you broadcast everything. So we have a mechanism we call NDN self-learning, which can improve this situation. You broadcast the very first interest, you get data back. But when the data comes back, the router can set up the routes along the way. So your future interest will only be unicast, not flooded or not broadcast to the entire network. So this will make this scheme much more feasible in the real situation. Of course, the first interest still has to be broadcasted, which means it only works in some kind of local environment. If we're talking about on the internet, then there's no way you can broadcast even the first interest. So there's from the consumer point of view, you can broadcast your request. And from the producer point of view, the producer, when it moves, it could announce its name prefix through the routing system. So the routing can keep up to say where to forward interest towards this prefix. Okay. Of course, this works, but it doesn't scale. If you have a lot of moving nodes, a lot of moving contents, that will actually end up with a lot of routes to each specific mobile node or mobile content. So this will not scale. It's a working solution if you don't have so many mobile content or mobile nodes. But if as the number goes up, your routing system will not be able to handle that amount of mobility and the dynamics. So the third solution is we set up some sort of rendezvous point. So even the rendezvous point doesn't move. Then the mobile producer can upload the content to the rendezvous point and let the consumer to retrieve from the rendezvous point. It doesn't require any form of broadcast or routing announcement to the whole world, nothing like that. It just, as long as the consumer and the producer, they agree on what the rendezvous is. As long as they share that information, then they can always use that to handle the mobility. Okay. It's very similar in concept to the home agent in mobile IP. But this is in the NDN sense, and we're going to see there's subtle differences here. But in very high level, it's similar to the mobile home agent in mobile IP scenario. Here's a little bit illustration. We have this mobile node right down here. The mobile nodes, of course, moves around and generate data under this particular prefix, UCLA, Alice, photos. And the consumer and the producer, they all agree using this rendezvous point, which is at UCLA, so with the name /UCLA. And this node doesn't move. So the idea is we're going to somehow upload the content generated by the mobile to the rendezvous point. And the consumer also know the rendezvous point, so it will just download from there. And here I deliberately make this line shorter, didn't go all the way to the rendezvous point, because the data may be cached somewhere here, and there may be routes. Because of this action, there may be routing entries created, so the interest from the consumer could go to the rendezvous point, could go to the mobile directly, or could hit any cache in the middle. So this is NDN, and we don't know, and we don't want to restrict from where you actually retrieve the data. But using this rendezvous point, they can sort of use the name, well, use this name as a rendezvous to make the content and consumer, they meet each other. So this is high-level idea. And if you look at this picture and look at this, basically there's an upload, there's a download. And downloading is trivial. The consumer just sends interest for this content. And that interest be forwarded either to Rendezvous or the mobile or the cache, and you get it. So there's nothing we need to do over there. But the question is, how do we actually upload the content from the mobile to the Rendezvous? Of course, if it was in the IP case, you just establish a TCP connection, you push all the data to the Rendezvous. But in NDN, we do the pooling. How do we pull the data from the mobile node? And that's the key question for this work. How do we pull it? We have two solutions we're working on, and the first one called a forwarding hint, and the second one called a kite. The idea of forwarding hint is for the rendezvous, learn about where it's not where, but learn about the name prefix that the mobile currently resides in. So in the previous case, if this mobile publishing data under this prefix, but it currently is at Arizona. So the routing system knows if there's any interest for Arizona, it's going to forward this way. But if there's any interest for UCLA, it will forward that way. Therefore, we need the idea of forwarding hint is we're going to send from the rendezvous, send interest towards the mobile with two names. One is a content name, and another one we call a forwarding hint. So this forwarding hint is for the network to forward the interest to the mobile. But this name identifies the content we're looking for. So this is idea of forwarding hint. And in the second idea called kite is based on the idea if we send from the mobile, send interest to the rendezvous, we can always do that because rendezvous has this UCLA prefix, and the routing system all know how to forward to the rendezvous. So we can send interest over there. Once we send the interest, think about it in NDN network, every router in the middle has a PID entry. That PID entry sort of establishes a path from here to here. If we can reverse the direction of those PID entry, somehow based on the PID entry, set up a reverse route, then we can get back to the mobile without doing any other like forwarding hint or other thing. We just look at how does the phone interest actually reach the rendezvous point. Then we just somehow reverse them back so that interest from the rendezvous can get to the phone and retrieve data back. So there are two two solutions we are working on. And so I'm going to go to a little bit more details on each one of those, but because we have time limited for this tutorial, so I won't be able to go all the way to all the technical details. If you are interested, you can talk to the NDN team people, or we can, there's also papers and code, so we can all get into more details after that. Any questions so far? Okay, so here's how forwarding hint works. The mobile, as I said, is right now is at /Arizona, but it's generating data /UCLA/edit/photo. If we somehow let the UCLA Rendezvous know that there's a content available under this photos, edit photos prefix, but it's right now is in Arizona. We let the Rendezvous know about that information. Then the Rendezvous will send interest as the interest name like this, just regular interest name for that content. But also has another field in the interest packet saying the forwarding hint is /Arizona. When the router in the middle receives those interests, they will look at the name, which is this part, when they try to match the content. So you're looking at your CS, your content store, see whether you have a cache. When doing that operation, you only use this data name. But when the node, the router trying to make a forwarding decision of where to forward this interest, it will consider both. So if it actually has a local source for this photos, actually it can forward based on this name if it has a route towards this. But if it doesn't have a route, which is the common case, you only have a route for this aggregated high-level prefix, you don't have a specific route for this, that's a common case. In that case, you forward based on the forwarding hint. In some scenario, you want make the forwarding hint as a priority, because you want the interest get out of this UCLA domain and somehow going toward it. So you need to make Arizona as take the priority. So that's why I say take both into consideration. But exactly how you do it depends on where you are and what are the routing interests you have, and you can make the decision. But basically, you have the two pieces of information, then the router can do inform the forwarding decision.
I have a stupid question. Why can't you use the location dependence prefix instead of using this forwarding hints? Why can't you just publish under Arizona, and then it is photos posted, and then have rendezvous point where you tell, okay, my new prefix is under Arizona, so you don't have to have this forwarding hint.
So that's a different way to do this, but the problem is then the producer, when they sign the data, they have to name and assign the data based on where they are. So I think that's much more problematic than doing this. So the producer, when they deal with the data, they don't need any change. They just say, I generate this UCLA edit photos, I name it, I sign it. There's no change. It's just when you retrieve the data, there's something actually.
This is the trade-off. Either you do the change in the forwarding, right, back and forth, or you make a change in the client.
Right. And
so with the location-dependent names, you only need to do two updates. One is to add the signing key and tell the rendezvous point about location-dependent. You need to do two things. You can get away without the forwarding.
But you need to.
If you're walking around town with your mobile, I mean, it can change every hour, right?
Basically, but you need to involve the application into this process, and I think that's
the transport layer.
But this thing, if you don't involve application, you can do once, and all that applications can use it. If you do if you make this requirement for applications, I think it's hard.
But that's how Skype used to work, right? We only did, so the rendezvous point was only to learn about the IP addresses, and then the old Skype, right? And then the parties, they were talking
but that's the point, only Skype can do that. I mean, if I have another application, I have to, as as application developer, explicitly implement this mechanism and design mechanism. So that's the point.
Okay.
I have a question.
Yes.
Coding the information, is it NDN system?
Yes. Yes, that's my next slide, or the slide after.
I have another quick question.
Yes.
How does the Rendezvous solver know that the mobile producer is in Arizona at the first place?
That's exactly my next question. Yeah. Thanks for asking the question. So there's some mechanism going to involve to let the Rendezvous knows the mobile is in Arizona. First, the mobile itself has to know that, and we do that based on some kind of bootstrapping mechanism similar to DHCP. Like you when you connect to this new network, you get some basic information about this network, and one of that information is the prefix of the visitor network. And then, how do you let the Rendezvous know? You could just send the interest specific let the Rendezvous know, but then you have to, because it's interest, so you have to put it in the name, and you only can notify the Rendezvous if you know it. If there are other consumers who want to retrieve your data, but you don't know, then you don't know to whom you tell. Our solution is to have a generic name lookup or mapping system called NDNS. In NDNS, it's similar to DNS, but it's mapping, not mapping from name to address, but mapping between two namespaces. The mobile will update the NDNS and say, hey, here is my name prefix, and here is the prefix of my visitor network. And then any consumer who's interested in the data, interested in retrieving the data, they can do a lookup, and given this name prefix, they end up with the current prefix of the visitor network. So with this general name mapping service, you can find out where to retrieve the content in the latest situation. And we can also apply it to handle the global routing scalability problem, but that's a different issue. Let me get to the second solution is called Kite, which Kite is a paper accepted by this conference. So Zhongdao will present the paper later in the conference with more details. So here I just give the high-level idea. Remember, this is our scenario. We want to upload data from the mobile to the Rendezvous. In Kite, we don't need to know the visited prefix, like the mobile is in Arizona or in somewhere. We don't need to know that. All we need to do is, for the mobile, it will send a special interest to the Rendezvous. And of course, that is addressed to /UCLA, so the interest will be forwarded to UCLA Rendezvous server. And this interest is signed, so we know it's from authorized mobile producer. Then what the Rendezvous server will do is to send back a special data packet called trace data. That special packet will follow the PID entry established by the previous interest. So follow exact path. But that trace data has some special component in its name. So every router in the middle, they're going to recognize this is a special trace data packet. And when they see that, they know, okay, I have this existing PID entry pointing to the Rendezvous. When I see the trace data coming back, I will reverse it and put it in the forwarding table. Say, for forwarding table entry to reach this prefix, the next hop is going this way. So the trace data is a confirmation to say, okay, let's reverse the path identified by the pit entries so that we have a working forwarding entries from the rendezvous back to the mobile. After that step, the rendezvous can keep sending interest towards regular interest towards the mobile and retrieve the data back. You see here, we don't need to know where the mobile is. As long as there's a working path starting from mobile to the rendezvous, then we reverse that and keep getting, then we can start retrieving data. So this is the idea, basically utilize the existing states already set up in the pit and just make use of that for the reverse data retrieval. This is a little bit complicated, but probably cover all the scenarios. So let me go through this. We have mobile here, which is Alice's phone, and we have a rendezvous server here. And this is the very first step is the interest sent from Alice. It's so-called trace interest. And AC, they are the routers in the middle. So when the rendezvous point receives this trace interest, of course, it will first verify it's signed by Alice. So it's not some random person trying to personating as Alice. It's signed by Alice, verify that. And then in the second step, it will send back this special trace data. The router A and C, they have the slash Alice as the regular routing entry towards the rendezvous point. But when they see this trace data, they will add this specific prefix, more specific prefix to Alice's phone with this the next hop. So to reach Alice's photo, the next hop would be from random point to A and from A to C and come here. Now, once this is set up, if there's a consumer here wants to retrieve Alice's photo, it will send interest. And those routers, the router B is not on this path. So router B doesn't have the prefix to reach the phone, but it can forward towards the rendezvous point. If it merges on this path, then A knows better. A knows, okay, you're asking for the photo and I know a better path. So A will forward it to the phone. If somehow Charlie's laptop is on this side of the network, so its interest for the photo will go all the way to the rendezvous point. And then rendezvous point knows, okay, I have more specific prefix, so it will forward it along this way to get data. Of course, if the data already in the rendezvous point, then it will just download from the rendezvous. So this is high-level idea of Kite. And Kite is maintained by soft state, so if mobile moves, the old states will time out, and we send interest and triggers set up the new states. So the current status for these two works, we published some papers and we have some simulation code to verify it actually works in our scenarios. We're currently working on to implement this. The first scheme, forwarding hint, the basic features are all working. We can basically use it to handle mobility in some basic scenarios. And for the Kite, the second scheme, we are finishing some supporting features in NFD, in the forwarding daemon. After that, we will start implementing the Kite specific mechanism. So that's the current status. I hope if people are interested, I hope we can get help from you guys implementing this.
Question?
Yes.
In case of Kite, Kite need to define new interest type. Trace you.
It's not a new interest type. It's same type, same interest, same data, but in the name we have a special component called trace. So if you see this trace as a component, you know it's a special interest or special data.
Trace interest is kind of different.
What? So,
Yes. Trace interest is different.
yes, trace interest is different, but really identified by the name rather than different packet format. Same format, but reserve the word to identify its trace interest.